Hey everybody, it's Mike here from the WeWrench shop. Welcome. Today we are doing something a little bit different. When I originally conceived all this, I wanted to put all my skills on display with restoring the M5, but I also wanted the channel to have a bit of an instructional element to it. So today, because we're at sort of a critical juncture, the engine is pretty much disassembled, I wanted to change pace a little bit, and I wanted to talk about the various precision measuring tools that are used in the automotive field. I want to go over their exact application and how they will apply to this exact project.
In an internal combustion engine, the distances in between some of the moving parts are extremely small, especially in interference bearings. An interference bearing is essentially two metal surfaces that are both round. There's an outer surface and an inner surface. The only thing stopping those two surfaces from crashing and welding themselves together is an oil clearance, okay? Just a thin layer of oil in between that those two surfaces glide on. That clearance that oil is in is roughly 1 to 2 thousandths of an inch thick. Now, just to give you an idea of how thin that is, the width of a human hair is 16 thousandths of an inch. So we're talking about distances extremely small. That's why you need tools that are so precise and that have such a high display resolution that you can actually measure distances that small. Now, the dial caliper that you see, the digital caliper, that can display 1,000th of an inch. But the dial indicator and the dial bore gauges that you see here, those have an even higher resolution. Each tick on those dials displays 5 10,000ths of an inch and even goes down to 1 10,000th of an inch, which is mind-blowingly small. The first tool that I'm going to show you is called the Vernier caliper. Now, this caliper is for general purpose use. It accomplishes all the tasks that I've been describing as far as measuring precisely, but there's a reason why that this tool is still in its packaging. A Vernier caliper really isn't proper for automotive use, and the reason is the resolution. When you take a look at the packaging, you can see what the resolution is in 1/16th, and 1/32 of an inch. Now, these type of graduations are not appropriate for automotive use. This is good for any kind of general purpose work, woodworking, plastic working, etc. But for automotive use, you need something way more precise than this. The other reason that I don't prefer this tool is because it's a slide rule type. It doesn't have any type of digital readout. You can make an error very, very easily if you are not seasoned in reading a device like this. So that's why this is still in its package and probably will remain there for the foreseeable future. This next tool I'm going to show you is the most versatile precision measuring tool that an automotive technician should have. Now, it's not the most accurate. It does not have the highest resolution, but it does have the greatest versatility, and I'll explain why in a second. This is called a digital caliper. This one is from Blue Point, which is Snap-on's sort of lower end brand. And here's why this tool is versatile. Number one, it has a digital readout, and it has a very, very good resolution. It measures down to thousandths of an inch, and you can see there's even a little half digit. You see that little 5 that appears sometimes all the way to the right? Well, that's 5 10,000ths of resolution on this thing, so it's pretty precise. The other nice part about this tool is the fact that you can switch to inches and millimeters on the fly. If you check out that blue button on the top there, that's what triggers that mode. The other thing that I like the most about this tool is that you can make several measurements with one tool. You can measure outer diameter, which you use those bottom clamps for. Those just clamp around something and it gives you an outer diameter reading. You can also measure an inner diameter with the top jaws. As you can see, as you spread the tool, as you open the tool, the top jaws spread out, and those you can measure an inner diameter with, and I'm going to show you that in a moment when we start using the tool. The other thing I like about it is that you can measure depth. And again, as you slide the tool, there's sort of an extension that slides out, and you can place the base of the tool against a surface, and you just extend the tool until that extension kind of bottoms out, and that will give you a depth reading. So this tool is very versatile. Again, not the most accurate. You should not be measuring oil clearances with a tool like this, but you can do a great number of general measurements, and that's what makes it so versatile. And we're going to do a quick measurement of the camshaft journal, the bearing journal. And you're just going to see me place the tool around the journal. We're going to maneuver it a little bit, get a quick reading, and there it is. For this next digital caliper measurement, we're going to come over here to the engine block off the M5, the S38B36 engine, and we're going to use the top jaws, and we are going to measure the inner diameter of the cylinder. So you're just going to see me maneuver the tool in here. And just a disclaimer, guys, you should never ever make this measurement in the field with this tool. I'm just doing this for demonstration purposes because this is the closest inner diameter that I have in the shop. So here we go. We're going to set the tool up, get it in there, make that measurement, and there you have it, inner diameter. Now for this next one, we're going to use the digital caliper to take a depth measurement. So what I'm going to do is I'm actually going to measure the depth of the coolant galley on the engine block here. You'll see me set it up. And we have the depth measurement right there. Again, versatility with this tool, that's its strength. Not accuracy, but versatility. If you don't have one, highly recommend you go pick one up. Now, the next thing that I'm going to show you guys are my micrometers. Now, a micrometer is for exclusively measuring an outside diameter to ultra high precision, okay? And the next question you're probably having is, well, why do you have 4 of them? The dial caliper, a digital caliper I just saw, kind of like had a wide range. So why don't you have just one big micrometer to measure all kinds of stuff? Well, here's the reason. A micrometer is only accurate up to a certain distance. Each of these micrometers measures roughly about an inch length. The smallest micrometer that you see measures from 0 to 25 millimeters, which is roughly 0 to 1 inch. There's another one that does 25 millimeters, 50 millimeters, 50 to 75, and the big one, which does 75 to 100. You cannot have an accurate micrometer over a large span. Like a micrometer that would measure 0 to 100 millimeters accurately doesn't exist because of certain tolerances. So that's why you have to have multiple micrometers for, to be able to measure all kinds of spans. Now, micrometers can be calibrated. If you take a look here, we have this little peg. I know it doesn't look like much, but this peg is probably the most accurate 75 millimeters you will see in your life. And take a look at what's printed on it. There's a temperature reading, 20 degrees Celsius, and the tolerance of the printed distance is plus or minus 0 micrometers at that temperature. So this thing is so precisely ground that, it's the most precise 75 millimeters out there you can pretty much get. It has these covers on it to protect it. As you can see, the micrometer almost goes to 75 flat. There's a little bit of a tolerance. That's probably because there's some dirt or something. You're always actually supposed to clean these tools. You just give them a quick wipe down before you calibrate them to make sure that there's nothing impeding. But these are some awesome tools and they can do some awesome things. So I will show you how they work. And what I'm going to do is I'm going to measure that same camshaft journal that I measured with the digital caliper with the micrometer. So we're just going to put it over the journal. And one thing I want you to notice is that I'm turning this thumb wheel at the end of the micrometer. That's not the actual handle. That's actually a clutch. Okay, and what that clutch does is it allows the micrometer to make enough contact with the journal without digging in. So that clutch just kind of spins after a certain amount of pressure is exerted, and that's how you get an accurate reading. You don't use the actual handle because you can dig into the work, and you just don't want to do that. So we're going to take the measurement. There we are. The next tool I'm going to show you are called telescoping gauges or snap gauges. And the purpose of these tools is to actually replicate an inner diameter measurement to be then measured with a micrometer. It's basically the poor man's dial bore gauge. So the way they work is they are like, the arms are spring-loaded. They're like little spring-loaded tees. And what you do is you insert these into an inner diameter bore. And once it's in there, you center it, and then you tighten the thumb screw at the bottom, and that holds the arms in a very precise manner to replicate that inner bore measurement. And then you take it out and you measure it with a micrometer, and then you can get your inner diameter measurement. And I'm going to show you how these work by performing the same cylinder bore measurement, but this time with a snap gauge. So we're going to take this cylinder bore dimension now, and what we're going to do is we're going to prep the telescoping gauge. We're going to compress it, and then we're going to screw in the thumb screw to retract it fully. And we're going to insert it into the bore. We're just going to make sure that it is centered. We've released the thumb screw, and those arms are going to articulate, and then we will tighten the thumb screw to get the measurement, and that's it. And remember, you have to use the correct size. There's multiple sizes for these telescoping gauges for the same reason there are multiple size micrometers, because they can only be accurate over a certain span. So now that we've obtained the inner bore measurement of that cylinder, we're going to bring it over to the micrometer and actually take an outer measurement of it. And that's how we use the telescoping gauge to ascertain the inner diameter of a bore. So it's pretty simple. You're just going to use the micrometer in the standard fashion. You get it around there, you take the measurement, and there you have it. This next tool I'm going to show you is the dial bore gauge. This tool is kind of exotic. It's pretty expensive. It's not a tool that you're going to find in most technicians' toolboxes, because most technicians don't have the desire or the need to measure bores with this type of accuracy. Now, it has the advantage over telescoping gauges due to its accuracy. Telescoping gauges have somewhat of a margin of error. A dial bore gauge is just obscenely accurate, and this one in particular from Fowler has a resolution of 1/10,000th of an inch. So every single graduation that you see on that dial indicator is 1/10,000th of an inch, which is pretty insane. The one thing about the dial bore gauge that can trip you up is setting it up. This dial bore gauge has quite a large range. It goes from 2 to 6 inches. And to set it up, you have to use a series of these anvils with possibly spacer washers to give you the right amount of margin. Now, the bore that we're going to measure is 93.4 millimeters. So what you have to do is you have to set the dial bore gauge up to extend beyond that, so you have some margin of measurement to move the dial indicator. So the first step is to insert the dial indicator into the handle. You want to get 1 full revolution out of it, and you'll see me doing that here. And then we're going to pick the proper anvil, which we're going to start with 3.6 inches. And then we're going to add the spacing washer that's 8/100ths of an inch. So it's going to give us 3.68 inches, which translates into 93.472 millimeters. So that's definitely over the cylinder bore, and it gives us the right amount of margin to measure. So when you measure something with a dial bore gauge, you're not going to get the actual measurement of the inner diameter. What you're going to do is you're going to get a measurement that you have to subtract from the zero measurement. And the zero measurement is the total distance of that anvil and a spacer washer if you include it. So I'm going to show you how to do that right now. With the dial bore gauge all set up, it's time to take it to the cylinder bore to do a measurement. And what you want to do is you just want to place it in there, and what you have to do is you have to feel it out. You have to sort of rock the dial bore gauge back and forth and notice the needle moving. Now, when the needle starts to reverse direction, that's how you know that you're at the apex. And the apex is basically like the maximum reading that you'll get before it changes direction. And that's essentially your reading. Now, I want to play this for you one more time and just slow it down a little bit so I can show you how to read this. With the dial bore gauge in the cylinder, you can see me start to rock it. You could see the dial make 1 revolution, and 2 revolutions, then it almost gets to a 3rd revolution, but it stops at that final digit. That gauge is showing me 29 thousandths of an inch. And the reason why I know that is because each graduation is 1/10,000th. So going all the way around, there's 100 graduations. And that's how I know that it's 10 thousandths every time that dial makes a revolution. So that's what it's showing you. The last tool I'm going to talk about is called the dial indicator. A dial indicator is used to measure movement particularly. This tool is not meant to measure some kind of bore or some kind of enclosed space. If you remember me mentioning earlier that the moving parts in the engine have very, very tight clearances. The oil clearances is in the thousandths of an inch. What's precisely the application of a dial indicator is to measure some type of external movement on a very, very small and accurate scale. So this dial indicator is made by Snap-on. As you can see on the face of the dial, it has a resolution of 5/10,000ths of an inch. So what that means, again, is that every single graduation that you see is worth 5/10,000ths. Every other graduation is worth 1,000th. It's essentially 5/10,000ths of an inch times 2, which equals 1,000th of an inch. So you can mount a dial indicator in 2 ways. You can use the built-in magnetic base, which is kind of cool if you're putting it on a ferrous metal surface that is attracted to magnets. These little feet kind of slide in and out of here. So you can mount it on an irregular surface and have it stick, and then you just lock it in with the lever. Or you can use the rigid mount for certain applications, and that is precisely what I'm about to show you. So as you can see here, I have the dial indicator set up on the cylinder head with the rigid mount. We cannot use the magnetic mount because this cylinder head is aluminum, so we have to use the rigid mount. Now I have it bolted down. If I were doing this in the field, I would have done it a little differently. I would have used one of the cylinder head bolts, and I would have found a proper nut for it to bolt it to the head deck surface. But I hunted all around the shop and couldn't find a nut anywhere, so I did it this way just for demonstration purposes. So this measurement that you're seeing is valve stem to valve guide clearance. And again, it's a movement that is probably about 2.5 to 3 thousandths of an inch. And what you do is you mount the dial indicator rigidly, and then you put the needle of the dial indicator onto the margin of the valve with it centered in the guide, and then you zero the dial indicator as best you can, and then you just give the valve a rock back and forth. And you can see how it might take a couple tries, but you can see how crisp that movement is. That means you're getting a good reading, that dial isn't wandering all over the place. So what I see here is the dial indicator reading 10 thousandths of an inch. On this particular reading, what you do is you take half of that because that valve can rock both ways. So the final reading is 5 thousandths, and that's pretty excessive for valve guide wear. Now I wouldn't take this to heart because again, this dial indicator isn't mounted as rigidly as it could. There's probably some play with how I have it set up. When I do this measurement for real, I'm going to mount it to the cylinder head, to the deck surface, and really get it set up well. But this is just a good demonstration for how to do it, and that's your dial indicator. There is one last thing that I need to mention about using precision tools, especially any precision tool that has a dial. If you are reading a dial indicator, you must read it straight ahead. If you see this camera angle, the camera angle that I was using when I was measuring the valve, okay, it was angled downwards. You cannot get an accurate reading while viewing it like that. You must view it straight on. The reason being, there's a phenomenon called a parallax error. And what that means is that an object that you're looking at may shift position if you look at it from an angle. So to get the most accurate reading, always read a dial straight ahead.
Thank you so much, everybody, for tuning in. I really, really hope that this video was informative. I hope I presented it well. If you like what you see on this channel, make sure you like, subscribe, comment. Check us out on Instagram at WeWrench Official. Check us out on TikTok at WeWrench. Thank you again, and I will see you next time.